So we have talked about power, we have talked about telecommunications help us to create communication gadgets like phones, TV, etc. So most of you, even right now during this class, we are doing it because some engineers sat down and designed the way devices can communicate remotely, receive signals, etc. So we are saying that engineering as a profession satisfies an indispensable and beneficial need to society. Number two, it requires the exercise of carefulness and judgment. So you cannot be very careless and lack of judgment when you are an engineer. You require to apply skills with care and with proper thinking and judgment. And number three, it involves activities that require knowledge and skills that are not commonly possessed by general public. So you cannot just wake up one morning and say that now because you're able to fix a bulb at your home, you are an engineer. It requires specialized skills and knowledge that you have gained over time because you have been tutored and taken to the university and gained those skills. And we can definitely agree that engineering meets those skills. Number four, it has group of consciousness for the promotion of knowledge and professional ideas and leading social service. So we definitely know that engineering as a profession promotes acquiring of knowledge, and for that reason it meets the characteristic profession. And lastly, it has a legal status and requires well-formulated standards of admission. You cannot become an engineer until you have met some standards that have been set out by the Engineering Board of Kenya. And I should say that when you graduate as an engineer, having spent 5 years, you don't become an engineer straight away. And this is important for you. What you become is a graduate engineer. A graduate engineer is like a trainee engineer who has joined the field. They do not have the required expertise to practice as an engineer. So what they will do is that they will join an engineering firm that has other engineers who are more competent than him or her. And now they start training them. You get exposed, you get some, what is famously called pupillage hours. You are working as an engineer, having first and foremost attained a degree. And therefore, once you have spent some sufficient time training as a qualified engineer, most of the times in Kenya, you need minimum of 3 years to become a professional engineer. So be aware or be alerted that you are very unlikely, unless things change dramatically, you will not become a professional engineer until minimum of 8 years have passed from today, meaning that is the case in Kenya, and laws do not change immediately. You require 5 years to finish your degree program and some 3 more years if you are lucky to start working immediately as an engineer. So for you now to apply and attain the title that you see people calling themselves engineer so and so. The engineering profession is career-based on logical, systematic problem solving that is generally high-tech or high technology, industrial or scientific fields. So we are now trying to define engineering, what it involves. And you can definitely see that it involves logical and systematic problem solving that involves high technology, both industrial and scientific. So that would be how you would characterize an engineer. They don't solve problems in a haphazard way. And what you observe even in the units that you'll be doing at engineering, engineers are always focused on solving problems. So you'll be seeing most of the tasks you are given is that you're given some tasks that engineer should solve. So you're given that consider a circuit A has this much. Okay, probably I should give you that as an example, just for the sake of illustration. Assume you have a bulb and you need it to light, and you are saying that there is a source of power there and there is some switch somewhere that requires you to have some resistance. That is not always how we draw resistance, but we can use it for now. So this is a switch. This is how we draw a switch. This is a bulb. This is a source. You're told the resistance has probably 100 ohms. Then you might be told how much power rating, how much voltage is dropped or across the bulb that is in that circuit if the current that is running through this circuit is equal to 1 amp. So that is a very simple problem that you would ordinarily solve, and you are told that the bulb has an internal resistance of probably 100 ohms. So that is a problem that engineer would solve, and you cannot solve this in a haphazard way. So you always need to know a few formulas that would be used to solve this problem. And that is why somehow over the years you have learned formulas, you have learned different problem solving strategies or ways of deriving a formula such that when you become an engineer, you will be in a position to solve problems in a logical and systematic way. So my purpose for giving you this example is not to show you how to solve that problem, because we are not yet there, but to tell you what you require as an engineer to solve problems. So you are going to be following some proper logic and systematic approach in problem solving. And whether the end result is a product, a process, a system, or a service, engineers need to consider safety, reliability, and cost effectiveness. So if you are a civil engineer, I have always given this example. If you are a civil engineer and you have you are building a road, but before you make a road, there is a river that is flowing. So you need to build a bridge here so that the cars that are coming are going to pass without collapsing. So this bridge needs to be supported by some beams. So what we normally do, we talk about cost, safety, at least at the minimum. You must provide safety such that the heaviest of vehicles that might be along this road, maybe a very long track, is able to pass through your bridge without crumbling. But at the same time, you must not use all the resources. Like if this bridge requires to have a diameter of 2 meters, you require to have some steel structure that uses probably minimum of what is famously called D18, and among others, such that the total cost of this bridge might be 1 million. If you as an engineer, you are incompetent and you build a bridge that costs 10 million, then you have clearly not considered one important characteristic that you must always observe, which is that of the cost. We normally talk about optimization, that you are not building the most expensive bridge as an engineer so that you can be seen that you have built a bridge. What you must always observe is that you are building a bridge that meets the minimum requirement so that it doesn't crumble, but at least it also observes the cost requirement or the cost constraint. So we always observe the constraints that we must observe at the minimum, and the constraints, some of them is safety and the cost. So that is extremely important as an engineer